European Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Let us continue our study of chemical reactions and stoichiometry. In this lesson, we will look at energy changes in chemical reactions. Nearly all chemical reactions are accompanied by energy changes. These energy changes take several forms: heat energy, light energy, electrical energy, and so on. Let us pause and perform the first activity of this lesson. Gather in small groups and discuss the following question. When bread is baked, does the bread absorb or release heat energy? Talk with other members of your group to answer this question. Please, go ahead.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Were you able to come up with an answer to the question? Good for you. When bread is baked, the bread absorbs heat energy. When bread dough is placed in a hot oven, it absorbs heat. If the bread has yeast in it, the bread will rise, and the heat from the oven will solidify the bread when it has risen fully. Yes, the bread is hot when you take it from the oven. You will need thick oven mitts to make sure you do not burn your hands. But that heat is not being released from the bread because of a chemical reaction. That heat is on the surface of the bread because the bread has absorbed the heat of the oven. The heat will slowly dissipate over time. That is why we let bread cool down before we eat it. Baking bread is a clear example of a chemical reaction that produces an energy change. But it is obviously not the only one. We can divide all chemical reactions into two groups: those that release energy as a result of a reaction, and those that take in energy to produce a reaction. Both of these kinds of reactions have fancy names: exothermic reactions and endothermic reactions. Let us look at exothermic reactions first. An exothermic reaction is a chemical reaction that releases energy in the form of heat or light as it proceeds. Exothermic reactions are represented in the form of equation: reactants produce products and heat. The burning of carbon with oxygen produces carbon dioxide and releases heat. That makes it an exothermic reaction. Take a look at your screen and we will watch an exothermic reaction take place. Watch as the man takes a small piece of sodium and places it in a beaker of water to produce an exothermic reaction. If I did not see it for myself, I would not think that something that looks like a pebble could produce such a strong light simply by dropping it into some water. Now, let us look at the other kind of chemical reaction: endothermic reactions. An endothermic reaction is a chemical reaction that absorbs heat energy. Endothermic reactions are represented by this formula. Reactants plus heat produce products. The reaction between carbon and sulfur to form carbon disulfide is an endothermic reaction because heat is absorbed in the reaction. Take a look at your screen and we will watch an endothermic reaction take place. Watch as the man mixes two chemicals to produce an endothermic reaction. This chemical reaction is not as explosive as the earlier one, but it is a powerful demonstration. The reaction drew so much of the heat out of the water on the small block of wood that it froze the block of wood to the bottom of the beaker. The amount of heat energy absorbed or released by a chemical reaction is called heat of reaction or change in enthalpy of the reaction. We use this symbol to describe heat of reaction. It is called delta H of the difference in heat. Its unit is expressed in kilojoules per mole. The change in enthalpy is the difference between the energy of the products and the energy of the reactants. Let us pause and perform the second activity of this lesson. I would like you to answer several questions to make sure you understand the important things we have been talking about in this lesson. First, which of the two kinds of reactions releases energy in the form of heat or light? Second, which of the two kinds of reactions absorbs energy? Third, what equation do we use to describe reactions that release energy? Fourth, what equation do we use to describe reactions that absorb energy? And fifth, what do we use delta H to describe? Please go ahead and answer these questions now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Were you able to answer the questions? Good. Let us go over the answers together. First, an exothermic reaction releases energy in the form of heat or light as it proceeds. Second, an endothermic reaction absorbs energy. Third, we use this equation to describe reactions that release energy. Fourth, we use this equation to describe reactions that absorb energy. And fifth, we use delta H to describe the amount of heat absorbed and released in a chemical reaction. That is all for this lesson, students. You learned about energy changes in chemical reactions and learned about two types of reactions: exothermic and endothermic reactions. Good work. Until next time, thank you, teacher. Thank you, students.